Hi, Algebra 1. In this lesson, we're going to be taking what we've already learned about quadratics and use that now to graph using the factored form. Here we go. Here's the equation in factored form for this graph right here. And your job is to use this to figure out the values for A, B, C, D, E, and F. Just from looking at the graph and seeing that they are intercepts, I know some things about some x and y values for some of these points. So I know on these x-intercepts that the y value has to be 0, so B and D have to be 0, and I know on the x-intercept that E has to be 0, the x value. I know on these x-intercepts that the y value is 0, so I'm going to set this thing equal to 0. And then I'm looking at does x need to be to make each factor equal to 0, because anything times 0 is 0. So in this second factor, if x is 2, 2 minus 2 is 0. So that means the whole thing is going to be 0. And in the first factor, if x is negative 1.6, that's going to make this factor 0, and then anything times 0 is 0. So that means that A is negative 1.6 because that's the negative x value, and C has to be 2. And lastly, for F, we know that x here is going to be 0. So if we plug in 0 for x, and we simplify that, we would end up getting a y value of negative 3.2 right there for F. Now we're going to graph two functions and compare them. So our functions are f of x and g of x. We're going to do f of x first. It might help to do some color coding here. Your job first is to fill out this table. You're going to be plugging in these values for x and then figuring out what your y value would be, or the output. So for example, for negative 4, I plugged in negative 4 for x. So f of negative 4 equals negative 4 times negative 4 plus 4. And then I simplify, and I end up getting my output of 0. This is what we end up with function f. And then when we graph those points, we see that parabola shape showing up right here. And we can connect these with a line because we could have any values in between. Now we're going to do the same thing for g of x. Just use a different color. Fill out the table first and then graph it. Here's what we end up with for g of x in the table. And then in our graph, again, we can connect these with a line because we could plug in any decimal or fraction in between there. And lastly, our x-intercepts right here for function f. We're going to see them at those 2 points. So negative 4, 0, and 0, 0. And the vertex we see right there, which is maybe easier to see on the table at negative 2, negative 4, the lowest point. Similar with g of x, our x-intercepts are going to be at 0, 0, and then at 4, positive 4, 0, and the vertex is going to be at 2, negative 4, the lowest point. Now in your book, it also says to make a couple of observations about how the two graphs compare. Please add a couple things that you notice with these graphs. You can talk about the vertex of each graph. You can talk about whether you see them shifting right or left. But whatever you do, please write down at least 2 things that you notice. Now we're looking at some equations in factored form. And first we're going to look at the x-intercepts. And remember, when you're thinking of your axes, x-intercepts are going to be on that x-axis. So you know that the y value has to be 0. So what does x have to be to make these equal to 0? When you look at f of x, remember that anything times 0 is 0. So in this one, if I'm looking at this first factor, I know that if x is negative 3, then my y value is going to end up being 0 because it's going to make that part 0, and anything times 0 is 0. Then you look at the next factor, and in that one, if x is 5, it's going to make that part 0. So those are my 2 x-intercepts. Now when you're figuring out the x-coordinate of the vertex, so remember, these are our 2 x-intercepts, and our graph is either going to go this way or this way. We don't really know which way it's going yet, but we know it's going through those 2 intercepts. And we know the vertex is going to be either here or there. And we can figure out the x-coordinate of the vertex. So when you're looking at this crude sketch that I made, we know that the vertex is going to be in the middle of these 2 x-intercepts. So if this is at negative 3 and 5, we have to figure out what's right in the middle, and that's going to be positive 1. So the x-coordinate of the vertex is going to be that x equals 1, meaning the coordinate point is going to be at 1, something, and we can figure that out by plugging 1 back into the equation. If I plug 1 in for x, I'm going to end up with 4 times -4, which is -16. So then my vertex is going to be at the point 1, comma, -16. In function g of x, we look at each term again. And in that first term, 2x, if x is 0, it's going to make that 0. And in the second term, x minus 3, if x is positive 3, it's going to make that 0. So I graphed my two x-intercepts right here. I know the vertex is going to fall right in the middle. So in between 0 and 3 is 1.5. So the x-coordinate of the vertex is x equals 1.5. And then if I'm going to find the vertex, I'm just going to plug in 1.5 for x into my equation. So when I do that and simplify, I get g of 1.5, I plugged in 1.5 for x, equals -4.5. So then that's the y-coordinate of my vertex. So now that's the point where the vertex is. I could then finish graphing this by plotting the vertex and then just drawing my parabola. And there it is. In the last function, h, I can see in the first term that if x is -4, it's going to make the whole thing 0. And in the next term, if x is 4, it's going to make the whole thing 0. I plotted my x-intercepts right here, and I know that the vertex is going to fall right in the middle, which is going to have an x value of 0. So the x-coordinate of the vertex is 0. And now all I need to do is plug in 0 for x into my equation, and I'm going to end up with 4 times 4, which is going to be 16. So my vertex is going to be up there at positive 16, and my graph is going to look like this. Looking at my first factor, I can see that if x is 7, that's going to give me an x-intercept at 7, 0. And if x is -11, that gives us an x-intercept at -11, 0. Right in between those is going to be an x value of 2. So that's going, or -2. So that's going to be the x value of my vertex. And if I know that x is -2, I just have to plug that back in to figure out what the y value would be. When you're finding that middle number, you have to think of these two numbers as just being on a number line. The x-axis really is a number line. And halfway in between is going to be -2 because it's 9 away from 7 and it's 9 away from -11. I plugged in -2 for x into the expression and ended up getting -81 as our y value. So I'm going to plot that right there at -2, -81. And then we can sketch in the rest of our curved parabola here. And we can see that just by finding our x-intercepts and the vertex, we can create a good sketch of what these graphs look like.